Good day, ladies and gents. Welcome to BK Mathematics, where we are making you a math genius. And this is example 4 on implicit function. And if this is your first time of you coming across this channel, please make sure you share, comment, like for everybody to benefit. Let's get into the problem and see what we're going to have at the end. It reads: differentiate x cos y plus y cos x is equal to 1 with respect to x. Then if you want to differentiate this one, let's start. We say solution. Let's say solution. Okay, now since we are given x cos y plus y cos x, then everything becomes 1. This is what we are given, and we want to differentiate this one with respect to x. The first thing that we have to do here, we make sure we use product rule to differentiate this one, because we are having x cos y and y cos x. We make sure we use the product rule well. Now let's start. To start with, let's try to differentiate. Now let's hold x constant. We differentiate cos y. Then differentiating cos y becomes minus sine y. But the rule says whenever you are differentiating y, you add dy upon dx. Okay. Then we say we hold cos y also constant. Then we differentiate x. Differentiating x, it is just 1 plus the same thing implies to this. Let us hold y constant. We say we hold y constant. Then we differentiate cos x. Differentiating cos x becomes minus sine x. Similarly, let's hold cos x constant. Then we differentiate y, and we know differentiating y becomes dy upon dx. Then everything becomes, this is constant, and we know differentiating a constant, it is 1. Okay, now the next step, what are we to do here? Let's just try to multiply it now. We say x multiplied by sine minus sine y, giving you minus x sine y. We have dy upon dx. Okay, now we say plus cos y times 1, it is cos y. Then we say plus into, now multiply this one, giving you minus y sine x. Okay, plus this one giving you cos x dy upon dx. Then everything becomes 1. Okay, now from this point, what are we to do here? Let's just try to collect like terms. We add dy upon dx on one side. Then we say this minus x sine y dy upon dx. This also dy upon the, let's add this, plus cos x dy upon dx. Then everything becomes, when this one is moving to this other point, becomes y. This is y sine, this is y sine x. When this one is moving, giving you minus cos x. And we know differentiating a constant, this constant becomes 0. Automatically it is 0. That's why I don't consider it in the next step. Then we factorize. What do you think it is common here? It is dy upon dx that is common. Then let's factorize and see. We have minus, this one becomes minus x sine y plus cos x. We already factorizing the y upon the x as a common factor. Then everything becomes y sine x minus cos x. Then what are we to do here? We divide both sides. Let's divide both sides by, let's divide both sides by minus x sine y plus cos x. We divide this on both sides. Then this is minus x sine y plus cos x. We divide it on both sides. Then if you do this cancel this, then what remains in this part is dy upon dx. This is dy upon dx is equals y sine x minus cos x divided by this minus x sin y plus cos x. So this is what remains. Then if you look at what we are asked to find, the question says we have to differentiate these equations. X cos y plus y cos x is equals 1. Then our final answer becomes 0 upon dx is equals y sin x minus cos x divided by minus x sin y plus cos x respectively. So this is what we are asked to find in regards to the problem that we are asked to. Then thank you for watching. Make sure you share, comment, like for everybody to benefit. Love you more.